Hello, everybody. My name is Michael Campos, and I'm an investor with Energy Impact Partners, an investment firm focused on the energy transition and decarbonization. Thank you all for joining us. I'm also a strategic advisor to Pivot's fearless leader, Jamie Beard, and her team at Project Interspace. So we're here to discuss a fun topic today, which is challenging global penetration assumptions, geothermal, and the 2050 energy mix. In other words, how big can geothermal possibly get? So audience, please drop questions in the chat box throughout the panel. We'll leave ample time at the end for Q&A, and we're eager to hear your questions. So to cue up the discussion, I want to highlight three models of the 2050 energy mix as it relates to geothermal. The first is the US EIA's 2023 annual energy outlook. The second is Bloomberg New Energy Finance's 2022 New Energy Outlook, and BP's 2023 energy outlook. I'm not going to show them to you, but I'm going to walk you through basically what they say about geothermal, and it'll be quick. So these are the three standard bearers in energy modeling, and when it comes to geothermal, they basically have one thing in common, which is ignoring it. So in the EIA's case, they lump geothermal into the other category, which totals less than 100 gigawatts total. In Bloomberg's case, they lump geothermal into the other renewables category, which is less than 10% of the renewables category. And in BP's case, they just mention it as an other source of lower carbon power alongside nuclear, hydro, and bioenergy. So it's not getting much love in these projections today. That being said, energy experts are famously bad at forecasting new energy sources. For example, the IEA repeatedly underestimated solar installations basically every year since 2002. And as many of us know, geothermal is not just a gigawatt scale resource, but a many terawatt scale resource. So what gives, and what can we do to change the picture for geothermal? Here to discuss are three of the finest minds in the field. Today with us are Dan Cohan, Associate Professor from Rice University, Ivan Kozak, Partner and Director of Applied Earth Science at BCG, and Tim Lines, Managing Partner at Oilfield International. So please take a moment to introduce yourselves, panelists, and from there we'll jump into discussion. Let's start with Dan, then Ivan, and then Tim.
Okay. Great, thank you. Great to be with you. So I'm Dan Cohan. I'm an associate professor of environmental engineering at Rice University. I'm an atmospheric scientist by training, so I've been looking at these issues in terms of how can we get ourselves off of fossil fuel electricity, fossil fuel forms of heat, and transition to options that don't have those air pollutant emissions, don't have those climate warming emissions. And we got interested in geothermal in two ways. One was we had been modeling the roles that wind and solar could play as complementary resources to each other on Texas and US grids, and found that they do complement each other, but there are about 10% of the time when it is neither windy nor sunny. So no matter how well you mix and match those sources, you need something else to be filling in. And then also got interested in the topic when I was writing my first book, Confronting Climate Gridlock, and was able to meet some people of the geothermal industry and see some of the excitement they had about technologies they were developing. And over the past year or so, we've been modeling using National Renewable Energy Lab's REEDS model and looking at what cost points it would take for geothermal to get more widely deployed. And in our modeling, we find similar to what those three outlooks that you pointed out find, is that unless geothermal's costs can come down, it isn't going to have a big role. But I think there is the potential of what we've seen, what made solar get cheap, what made wind get cheap, what made LED lights get cheap, is that learning by doing those curves. And we found that if you were able to achieve the sorts of targets that Department of Energy is aiming for in its Earthshot initiative, that could start getting you on the path that with the right incentives and the right policies to go with it, that you could start seeing a bigger role by the 2030s or 2040s.
Great. I think I'm up next. Good morning, good afternoon, good evening, everyone. I'm Ivan Kozak, partner with BCG in our Houston office. I'm dialing in from Riyadh tonight, so it's good to see everybody. At BCG, I lead our applied earth science topic globally, and what does that mean? Well, I basically work at the intersection of technology, research, development, and deployment, all as they underpin clients' business strategies. And it's really about building competitive advantage. And so that's where I'll ground a lot of my thoughts today in terms of how clients that are operating on the ground level of the energy transition, how to help them address the transition in a way that builds competitive advantage for themselves, whether that is corporates, municipalities, small communities, whatever it is, just thinking about geothermal as a lever for building competitive advantage. And I think that's perhaps a nice complement to what Dan's talking about, because I think cost is definitely necessary to achieve. And I'm definitely a believer in BCG's experience curve and how other sectors have marched down that experience curve over time. But I also believe there are other factors at play that could make geothermal scale over the long term by 2050. And I've got about 5 pillars of those in terms of resource expansion, market development, capital infusion, more talent, R&D, and I think that those are some nice complementary aspects to bring to the discussion as well. I'm a geoscientist by background, cut my teeth in the industry at Exxon and then at Schlumberger. So really a living example of pivot, and very, very passionate enthusiast for geothermal. So nice to be here today with everyone.
I'm Tim Lyons. I've been in the energy sector for about 45 years, primarily in the oil and gas sector, but I also spent, I think, 8 or 9 years with the European Commission in energy policy with the Eastern European countries, trying to help them join the European Union, the accession treaties. And I also, within that role, I looked at some depth at district heating and how it can be regulated and managed and benchmarked in order to make it as appropriately beneficial to the customers, given the constraints it's under. Around about 2 or 3 years ago, I got interested in geothermal energy, partly because my society, the Society of Petroleum Engineers itself was, and they asked me to get involved on a couple of committees. And then a bit later on, Jamie Beard I met, and she asked me to look at a report that was being written in Texas called The Future of Geothermal Energy in Texas. And that really got me interested, because I used my analytical skills as an oil and gas engineer to look from the bottom up as to what geothermal could look like on a global scale. For the moment, ignoring the cost element, but just saying, actually, what can humankind do in the next, before 2050, in terms of penetration of geothermal? And I wrote that at some length in this report that was released in January. And the highlights were that using current technology, current oil and gas technology, transferring it across to the geothermal sector, you could achieve something in the order of 12% of the electrical energy inputs for the globe in 2050, and more like 20% of the direct heat energy. But if you then invoke some of the R&D that the Department of Energy in the States is some funding at the moment, and some of the extraordinary advances in drilling technology that you're seeing over in the last year alone from the likes of NOV and then the Forge facility in Utah, then if you start to invoke what might be the case in 2030, you can increase those figures to 75% of the total electrical energy required for the globe in 2050, and 100% of the direct heat, or the connected direct heat that the globe has. Now that's technical, and that's deploying oil and gas resources as they are now. So for example, at the moment, the globe drills roughly 60 to 70,000 oil and gas wells a year. If you drilled 50,000 geothermal wells, then you can achieve the numbers I mentioned there, roughly 12 to 20%, 12% of electricity and 20% of direct heat. If you double that number of wells and use some, which is still within the precedent, in the years 2000 to 2002, the oil and gas industry drilled over 100,000 wells. If you did that and you increase the productivity of the wells that are drilled, which is what the current research is talking about, that's how you get to those extraordinary figures. So technically, if there were a will, and we could get the costs in the right place by 2030, then geothermal can do what it ought to do, which is be the dominant force in terms of renewable baseload supply and other things within the energy sector.
Well, great. A lot to dig into on all 3 of these points. So maybe, Dan, let's start with you. So we've all looked at these energy systems models. Some of us have even made them. And we've just sort of heard the state of play. Would love to get your take on what has led us there. What assumptions lead modelers to basically write off geothermal as a significant energy source on the global scale by 2050?
Right. I think the biggest driver has been the relentless decline in the costs of solar at a much faster pace and much deeper cost reductions than had been thought possible 10 years ago. If you look at the IEA forecasts that came 10 to 15 years ago, they knew the cost would come down as you had learning by doing, as you had technological learning, but they thought by 2050, the costs would still be twice as high as they actually are today. And so many of the outlooks before missed the solar boom that's gotten underway. And when you start factoring in where solar costs have gotten, and if you assume that that keeps going forward, if you assume that the batteries keep getting cheaper, the wind gets a bit cheaper, then what the models want to do is go to the cheapest option, and that's solar. And we see that in the real world. Solar is now topping 300 gigawatts of deployment a year, which is a few times the levels that IEA thought we would be getting to a couple of decades from now. And so I think that growth is there, that's underway, and it just makes a moving target that other sources have to meet. If we assume that those cost declines happening, we know enormous amounts of capacity is being added in China and elsewhere in the world, and so it's a moving target that geothermal, that nuclear, that any other source needs to compete with. And yes, there is a role to balance in, but what models tend to do is they tend to build a lot of batteries if we assume it's a decarbonized grid, or to keep a lot of natural gas power plants around, maybe not deployed much, maybe just deployed when it's not sunny or not windy, but that tends to be what models want to find when they cost optimize. If we don't squeeze emissions out of the grid, if we allow emissions to continue, then it's often a mix of solar, wind, batteries, and gas that dominate the modeled world future grids.
Right. So that makes sense. I'd flip the question around and maybe open it up to anybody else who would like to chime in. So what features in an energy model actually favor geothermal? At what point does geothermal wiggle its way into these models?
Well, can I just make a tangential point here that what Dan's talking about is electrical energy, and I just want to make the point that the most sensible use of a hot substance is to heat something else rather than to transform it into electricity, where you're at a thermodynamic disadvantage to fossil fuels, which can convert energy at 800 centigrade, whereas typically we're looking to convert energy at 200 centigrade or maybe 150. And so you have a thermodynamic efficiency disadvantage straight away. By contrary, if you look at how you can use geothermal superheated water, then you can use nature to overcome the latent heat of evaporation, which is actually a huge part of the total energy required to lift water to a steam that's used in a typical industrial process. And so rather like Dan was saying about when things were needed a top up, you just go back to natural gas. The same, to my mind, is the way we should look to deploy geothermal energy, which is that you use it to take most of the energy inputs to get yourself into a steam, maybe at 150 centigrade. And if you need to raise that steam to 300 or 400 for a cement plant or something like that, then you use natural gas, and you don't use very much. It's quite a low enthalpy input from the natural gas. So that's the first thing I'd say, is that let's play to geothermal strengths, not to its thermodynamic disadvantage.
Great. Any other points to add on this question?
I think what I would add is, I think that we touched on at the beginning of the conversation, which is models can provide some interesting guidance, but we are very good at forecasting some things and very bad at forecasting other things. And I think just as people, we tend to bias ourselves on kind of extrapolating the current situation, the current scenario, but externalities happen and innovation happens. And I think I tend to look at things at much more of an unconstrained problem, just to kind of look at the resource first and to say, does it make sense given sort of the technical resource that we have? Let's just take it in the United States, and the innovation that we see by basically very near-term types of tech transfer, from oil and gas and taking advantage of EGS and other areas for AGS, is it reasonable to assume that in that kind of a scenario, with innovation and not necessarily even grid scale geothermal, could we be seeing a growth rate that would put us on a different track? I'd like to just sort of toss that in there to say that that models aren't everything, I think, and that we do see a pathway perhaps on the optimistic side of getting to an order of magnitude increase in potential by 2050, at least in the United States, with advances in EGS. I think that's a counterpoint, I guess I would say.
Come in on there for a moment, because you've mentioned the US, and actually of all the markets in the world, you're choosing the one that's least likely to be able to adopt geothermal at scale. Just because pretty well the price setter for electricity generation at the moment is natural gas, when in base load at least. It's certainly not for higher supplies where solar comes in. But natural gas in the States is roughly $3 a million BTU. If you look at Europe for the moment, I think it's 14, something like that. North Asia, it's 14. Japan, it's 12. So 3, 4 to 5 times the price. Now, if you're trying to compete and bring technology, oil and gas technology, especially to geothermal, the place to do it is where the price of electricity is the highest. So my view is we should, as an industry, be looking to Europe, which is already very interested in doing this, as ever. Loop and Gerätschried in Bavaria, for example, with a $90 million Horizon grant. And those are the places to say, well, can we test this technology and drive down costs where we have a reasonable chance of roughly matching what the electricity cost is in that country anyway.
I want to come back to
a really important role as well for early adopters and for companies and governments that are driving procurements, driving adoption before it's quite the cheapest option. So companies, I was just at a meeting of the International Energy Agency in Paris, and Google was there talking about how they're making the move, deciding that they commit, even though the law doesn't require it, but they're going to get 24/7 in location clean energy, and you can't get that with other options. And so when companies do those pledges, when governments and others make those decisions, that can get you down the learning curve in the way you need to be. That those actors and those sorts of decisions usually aren't captured well in the models.
Yeah.
I want to come back to the point about natural gas, because often in decarbonization circles, we hear a lot about the solar story, the wind story, the battery story, increasingly about these technologies coming way down the cost curve faster than anybody expected. But we've actually had a different energy revolution in the last decade or so, and that's natural gas. And geothermal happens to look a lot more like natural gas than it does a solar panel. So I'd love to open it up to the group. What other lessons could we be taking in the geothermal field from natural gas's rise to prominence?
I'll just kick things off with some initial thoughts regarding natural gas, because I think actually the LNG form, is an interesting analog for geothermal for a couple reasons. But first and foremost, in my mind, it's that geothermal developers and the geothermal industry overall, as an outside observer and increasingly a participant in the industry, I think we have to do a much better job of market development. And I think that if you look at the history of LNG over time, it was a resource looking for an end use case and a demand center. And so a lot of the developers in LNG needed to put not just their technical hats on, but have a very robust commercial team and innovative commercial teams to find those markets and long-term contracts to justify the CapEx. I see us in a similar situation today, where we're very focused on the technical side of the equation, but not so focused on understanding what are the stacked pay of different types of enthalpy applications across different markets, and working with those end users, working with the regions and the countries to develop those demand centers, develop those industrial hubs that could take advantage of a scaled geothermal development that aren't even in consideration today. And so if we look to LNG and natural gas and the opportunity that low-cost feedstock and long-term contracting and off-taking has provided a boost to the global, increasingly global commodity of natural gas. I think that we could do exactly the same thing with geothermal and following that pattern, because it's about designing those white space opportunities, new business models, new hubs that aren't even necessarily connected to the grid for those types of competitive advantages for C&I and for residential applications that aren't even thinking about geothermal today.
Another lesson to take from natural gas is to have humility in our inability to predict the future and our inability to model what's coming, and to challenge the assumptions that have become the conventional wisdom. When I started teaching at Rice 17 years ago, one of the focuses of my energy and environment class was how much natural gas importing do we need to do? How many LNG import terminals do we need in the United States? Because we had the priciest natural gas in the world. We knew that our natural gas production was declining. We weren't going to have enough. We need to import from Qatar and elsewhere. And so there were very smart people running very, very sophisticated computer models to predict, do we need 5 import terminals or 10? And of course, within a few years' time, the market shifted and we were looking how much to export. And so, what we think we know, what we're so sure the trends are going to be, can really change if technology and costs shift in a way that we didn't expect.
I really want to heartily agree with what Ivan said, but actually what was going through my mind was actually midstream pipeline operators in the USA who are the market-facing part of the natural gas industry. And they're the ones that get to know who the customers are and what their requirements are, and then they load balance and all those kind of stuff. And that leaves the oil and gas upstream operators to get on with their job, and all they've got to do is make sure they meet the specification that the midstream operator needs. And I see the very same in geothermal. And although I find it even more daunting, because if I look at, for example, the different potential opportunities to supply steam, process steam to industry, you've effectively got to understand the requirements of each of those industries. And I made this point in another panel session, but for example, pasteurizing milk requires you to raise the milk to 70 centigrade. Actually, it's a really easy process to understand and to supplant with geothermal. But cement making or paper manufacturing, paper mills, it's hard. And unless you can talk their language, then they're not going to listen to you because they won't take you seriously. And so that's perhaps where the equivalent of what Ivan was saying is so important, because you have people who know the customers and what their needs are in both a process engineering sense and indeed for a demand supply sense.
We've talked a bit about market development here, and I want to shift gears just slightly to talk about emerging markets for geothermal. So I believe all of us here, except for Tim, are based in the US, and much of the geothermal conversation happens to be around the US, especially given the US oil and gas industry's forthcoming pivot into geothermal. But it's far from the only place you might want to develop geothermal resources. Maybe it's far from the best place you'd want to develop geothermal resources. And so I'd love to open it. Maybe we'll start with Ivan about what other markets do we think that geothermal developers ought to be targeting?
Yeah, no, I think it's a great question, because I haven't seen all the sessions that have happened at this conference, but I really love the theme of building the bridges and having the kind of local kind of perspectives. I was watching the one with for Kenya and part of Nigeria, and the stories of Kenya is the 8th largest power generation country in the world right now, and I think that a lot of the countries like the US could be learning a lot from the experiences in Kenya, places like Kenya and Indonesia, Turkey. I think that in terms of rate of deployment and rate of new projects, those countries are leading the charge in many ways. And so what I would say in terms of the opportunity we have for the emerging markets, taking the learnings from those places, which honestly have been more on the conventional side, if we combine that with some of the progress that we're making on EGS and AGS, I think that emerging markets have a real opportunity to be an essential part of the conversation, because they're not necessarily kind of the typical Ring of Fire or mid-continent rift or kind of East African rift types of players, but they have a real opportunity to kind of leapfrog a lot of other countries into the energy transition and make their energy deserts, in a lot of way that we talk about in the energy industry, the energy deserts and sources of power generation and heat use, leapfrog the technologies of carbonization and actually go straight into decarbonization and turn energy deserts into energy oases. And I think that's a big theme for emerging markets, because it can start with heat, it can be combined in parallel with the power generation as well, and it can be modular and flexible and provide pretty resilient seeds of opportunity for those countries in ways that a lot of other grid scale, utility scale, power gen, and heat sources can't do. And so you can start small, create those modular resilient seeds there, and grow that deployment. And what's great about geothermal is I think it can cut across a broad swath of use cases that are impacting emerging markets, not just power gen and heat, but district cooling, district heating, desalination, agriculture, and I think that those are all questions that we can be answering with geothermal potentially played the right way in emerging markets. I see it as a great opportunity.
Tim or Dan, anything you'd add to that point?
I think those are great examples. Many of those markets where there's shallower heat, where hydrothermal could be an option, where grids aren't as well prepared for intermittent resources, and where in some cases natural gas isn't as available or would need to be brought in with LNG, and where geothermal could really be a least cost option and really address some of the energy poverty problems, really help provide more round the clock power in places that haven't had it or haven't had enough of it.
Yeah, I mean, undeniably, what the thing to do is look around the globe, just like I was saying, for where geothermal is least cost or least competitive, and has other advantages like no pollution, etc. But I would caution in one way, which is that ultimately these projects have to be have to have backers, have to have equity investors, and equity investors will be looking at the geopolitical risk of your target geothermal project, as well as all the other issues around whether a project can be managed on budget and control there, and everything around the country is important. I remember being shocked once at an oil and gas investment conference, probably 10 years ago now, and there was a very large amount of private equity money available to be deployed into oil and gas at the time. And I asked the question of how much of that is going to go into Middle East, Africa, Europe, and the answer was less than 5%. 95% would go in the States, because they know exactly how that market works and they know what profits they can make. They were not prepared to risk their equity when they can make a big return back home. And I just make that point that ultimately we're going to be looking at politically stable economies with high energy prices to start this thing off. It would be great to work in countries that really, really need it, but someone's got to pay. And if that's going to be multilaterals, then you're going to wait 5 or 10 years before the money becomes available, by my normal experience.
I think just to add to that discussion, I guess I see in many of these countries, there's a multifaceted approach to what needs to be and should be developed. And to bring in the mining topic, a lot of countries that have a need for potential for geothermal development also are very rich in mineral resources, and we all know we need more mines, if we're going to be electrifying as well. And I think that I think we're in a world where we can see geothermal diplomacy. So it's not all about private equity, but it could also be geopolitically savvy moves to be investing in countries, and helping to influence and help countries develop that have the mineral resources that are needed, as well as helping them and assisting develop their own geothermal economy that's diversified across different sectors as well. So I do agree wholeheartedly that we need to unlock capital, and I just hope that it's a an optimal mix of that capital instead of flowing to the most developed countries, because I think that there's a lot of value in that diversification just for geopolitical reasons as well. But we do need sources of patient material levels of capital from a number of sources. So definitely agree with that point too.
We've got a little under 15 minutes left, so let's shift over to some questions from the audience. And by the way, we'll keep them coming. These are great questions so far. We'll get to as many as we can. So first, one audience member asks, to what degree will public distrust of drilling and fracking be an obstacle to geothermal or achieving scale? Any panelists have thoughts about this question?
I'm facing it in several jurisdictions around the world now, and pretty well everybody always asks the question first. I think this is about education and argument, and yes, it is most certainly a hurdle that has to be overcome. But rationality is on the side of geothermal, and it can help to try and reduce the emotional impact. And a lot of people have said to me, why do you still use the word fracking? What about fissile or other words, fissuring or something like that, that are not so emotionally loaded? I think that the Department of Energy has changed the terminology it uses in the state.
Any other perspectives? Okay. So here's another question. So we drill something like 60,000 wells a year right now. The scale is already there. Why isn't more of the world talking about this? I mean, other energy techs are going to have huge problems scaling due to lack of workforce, but here that's not obviously the case. We already have a lot of workforce drilling the wells. So what do we think about transitioning a fraction of those 60,000 wells per year to geothermal?
Yeah, I think so. You're talking about the 60,000 oil and gas wells or something that we're drilling a year. Yeah, I think we're drilling a couple orders of magnitude fewer wells for geothermal on that front. But I think it's a great question for OFS companies, to consider. I think that we can't scale geothermal by waiting for downturns in the oil and gas industry. We need to have both, and it's a margin play for OFS companies. And I think that in the near term, we've solved that by OFS companies taking positions in startups or investing in the technology and needed for those developments, but not in a material way. So I do think that is a challenge. I personally think that down the road we're going to see enough of a backlog of geothermal prospects and projects that could bring about a business case for a dedicated geothermal multi-line, service provider. And right now we're relying on the traditional big three really for those services, but there could be there could be a good opportunity down the road. But right now we're relying on those OFS companies to say, yeah, we do see growth and maybe not accretive, but maybe not super dilutive margins on the geothermal side, because they are lower cost wells, but they are ripe for innovation as well. And so I think that we do see equipment players and service companies starting to see that more, but we need more of it, definitely.
Relatedly, what role do you all think an oil price crash would play in the development of geothermal, or by that same token, extended run of high oil prices?
Well, I mean, the theme is that the higher the competing energy price, the more attractive the renewables become. So that's the one side. The other side is it depends how much oil and gas demand is created to soak up the oilfield services company's capacity. And I would, in some ways, that relates to the earlier question, which is the 60,000 wells is, of course, was the basis of my analysis as well for the total penetration in 2050. Is partly based on the fact that the IEA's forecast in 2022 looked at a reduction in the demand for oil and gas from where it is now 100 units, as you like, down to about 20 units required, for example, raw materials for making petrochemicals. So if you like, there is going to be potentially a whole load of capacity and human resources who are ultra skilled at doing all this, who will no longer have obvious jobs in the oil and gas sector. So it may happen naturally, a race against time before they decommission the rigs and the other equipment, but in principle, the two could dovetail quite nicely.
Great. So shifting gears a little bit, obviously about a year ago in the US, we had the IRA come to be, the Inflation Reduction Act for those not based in the US. I'd love to hear some commentary from the folks on the panel about what we need above and beyond the IRA to help catalyze growth.
What we finally saw with the IRA is geothermal being put on closer to a level footing with the other clean energy options. That for a long time, geothermal wasn't getting as generous tax credits and other opportunities that its competitors were. It wasn't even getting on the other side of the regulation equation. It was harder to drill geothermal wells than it was to drill an oil or gas well, and so it was sort of at a disadvantage compared in both of those ways. I think with the IRA, it opens up a lot of opportunities, opens up the DOE's loan office that's able to give out a lot of money for some companies as they start to commercialize these technologies. But it's still a long way from there, and there are some ways that it's so generous in some technologies that it subsidizes the amount that it's putting into nuclear, for example. They is providing competition in that regard. I think there are also opportunities perhaps cross-sector in that, because there are such very generous subsidies now for carbon capture, will we start to see more of these synergies between geothermal and carbon capture, where the temperatures of the heat coming out of geothermal can be really powerful for certain technologies of how you might capture carbon out of the air.
I must come in just to talk about something a bit different, which is common resources standards for the financial communities around the world, of course, especially in the USA. But if you look at, for example, the oil and gas industry with its PRMS resources standard, or the SEC one, or the Canadian one, or others, then that allows financial communities to understand in an unbiased way what the resource is and probably what it's worth. And in the geothermal sector, we have nothing like that. There is the United Nations resource standard in a three-dimensional matrix, but the financiers I've spoken to haven't taken to it because it's pretty far away from what they're used to, which is the kind of PRMS type layout and standard. And my view is that if we could get an accepted global standard for the financial community, probably based on the UNECE work, then that would unlock a lot of conversations between owners of assets and potential investors in assets.
I just would bring it back to the capital question that you were talking about, the funding. I mean, if we're here to talk about what it's going to take to accelerate geothermal, the research, development, deployment capital gap has to be closed for geothermal, full stop. I think that the IRA was very helpful in terms of kind of getting a level table, but I think that I would like to see more capital being funneled to RD&D for geothermal, simply based on the resource potential. Agree, standards are needed, but at a technical resource level or just an overall quantification level, the amount of capital flowing to geothermal based on estimates of technical potential are dwarfed by other types of technologies that are out of the money today, or have even more issues in terms of scalability and deployment economically. So we need to see much more on that front.
Great. Tim, we've got a question for you. It starts with, I agree with Tim's point. We need to play to our strengths. Do we have global research from various industries that have incorporated direct use of geothermal in areas like agribusiness, processing, and manufacturing? As you've pointed out, that might be the best thing to do with geothermal heat, just use the heat. But in the same way, it might not be as straightforward to model as some of the electricity models that we see.
I don't know. If the question is, Are there use cases around the world which demonstrate what the heck you can do? Absolutely there are. And there's a research paper by Lunt and Toff in the last 2021 conference, which I commend everybody to read, because it's eye-opening about what countries around the world have done with direct heat, most especially China, which tends to be top of pretty well every category and very inventive and creative. But your question is different, which is how do we model that? And on that, I have to say, I'm not given any thought. All I know is that at the moment, the amount of money, of energy that's spent, for example, in the US is the order of $60 million, I think, on industrial energy from geothermal. It is not even a drop in the ocean. And so almost anything you can do anywhere is going to be beneficial to the environment if you can engage with one of these big industry users of fossil fuels, especially number 4 heating oil, which is a lot more expensive than natural gas. I can't answer your question precisely. My apologies.
Anybody else want to take a swing at it? It's a tough one. Okay, we've got just a couple minutes left. Let's zoom out a little bit. So when you think about the long-term limitations to geothermal, are they primarily a subsurface problem, a surface technical problem like turbines and generators, or a regulatory and industry framework problem?
I would say it's a people problem, honestly. I think that to add the 4th category in there, one of the topics I'm most passionate about is just talent and long-term sources of talent for subsurface, whether it's geothermal, mining, other types of topics. I think that we're seeing the enrollment levels for reservoir engineering, for geoscience plummeting, and it's going to take a lot of reinvention, a lot of to bring about a renaissance, not just domestically in the US, but around the world, to focus on that sustained level of talent that will then generate the innovation and the needs for the capital funding and for the other types of unlocks that you mentioned, the other 3 categories. But I would say it's a talent and people problem, first and foremost.
Yeah, to add in my own 2 cents here, this is something that I've thought about a fair bit. I agree the talent problem is a big one, and just big dumb numbers. The oil industry is roughly 1,000x the size of the geothermal industry, which is it's a stark difference, but it means that a 1% talent transfer from oil and gas to geothermal would 10x the geothermal industry. So it's something to think about. It doesn't take a whole lot of movement to make a big difference at this point.
That's right.
Okay, so go ahead.
Look at demand. I think it's a people problem in a different way. I think it's a people problem because you need people to demand they want it. And one of the ways of doing that is to educate them. And one of the things that I and Project Innerspace and others have been pressing for is how do you disseminate information that's useful to everybody in the world about the geothermal potential beneath their feet and how that could be applied to help them with their industry, their agricultural process, whatever it is. If you get people through that's kind of, and also through education of pupils and at university, then I think you'll see the people asking for it, and then after that, everything else will make it a lot easier.
Great. So we're about to wrap up. I want to wrap up with one last question for each of the panelists. Maybe let's start Dan, then Ivan, then Tim. If you had to place a bet on how much of the energy mix geothermal is by 2050, coming back to the title question of the panel, what would you bet? Let's do percentage of total world energy mix.
Mm-hmm. I mean, it's such a nonlinear question. I can see a scenario where it doesn't take off, and if we don't develop the technologies in the next 5 or 10 years, it stays below 1%. I can see making that inflection, some of these technologies that are just in the demonstration stage right now, proving out, scaling up. I think you could get to 10 to 15% with an optimistic scenario like that.
Yeah, I agree with what you're talking about, Dan. And you're talking the questions around total energy. So power, heat, everything. Yeah, I'll see the ceiling of Dan and call that my floor. So I'll say 15 to 20. I'll be more bullish. So why not?
of course, I'm already in writing on this point. So I said that that I could not see a reason why we couldn't have, technically at least, 12% electrical energy and 22% direct heat, and that if we really did an Apollo mission, we could easily get to something like 3/4. Now, there we are. So I'm gonna say, if you want, my bet is going to be on 25% of the total prime energy supply will be geothermal by 2050.
I love it. Okay, with that, we'll have to wrap up. Thank you all for your attention and time. Thank our panelists for joining us, and I hope you have a good rest of the conference.